Dr. Alexandre is from Lisbon, Portugal, where she got her bachelor's and master's degrees in forestry at the University of Lisbon. And in 2009, we were lucky enough to entice her to the U.S. Through a Fulbright exchange program to pursue her PhD. And the project was later funded by the U.S. Forest Service in combination with the program. And she graduated in 2015 with her doctorate from the University of Wisconsin-Madison. And I believe today's presentation is work from that time. And the Wisconsin DNR, Department of Natural Resources, is lucky enough to have her now as a forest ecologist, silvicultural specialist. And we're lucky that the DNR was willing to let her give some of her time today to share her research. And as you knew from the topic, her PhD focused on building losses due to wildfire and the influence of human disturbances in the wildland-urban interface, the WUI. And so that's today's webinar. So with that, you're done with me except for in the chat window, and I will continue to monitor and will hold questions till the end. But with that, we can turn it over to you.
Okay, thank you, Xander. So can you hear me and see the presentation okay?
Yes, it looks great.
Okay. Okay, so thank you everybody for being here today from wherever you are in the world, which is, I love this format because it provides a lot of opportunities for, people to listen to research. So as Xander mentioned, my topic was on building losses to wildfires in the WUI. And before I do that, I would like to acknowledge some people. I don't know why this is not changing. Okay, here we go. So my work wouldn't be possible without a set of students that collected all the data that you will see, which is quite impressive, but also, of course, all the funding sources and support that I had. So, as you all know, wildfires are a natural part of ecosystems. And just so you have an idea, I updated this from my from my presentation from my PhD. Just in 2018, 25,000, more than almost 26,000 buildings were destroyed. Of these 25,000, 2,700 were residential. It's a lot. It was a little higher than the average. They've been collecting this kind of data since 1999. And so as you can see, wildfires have a lot of economic consequences, public costs, and there's a lot of federal resources that are used for both suppression, but also for fuel treatments. And these are preferentially allocated into wildland-urban interface areas. Oh, this is not working. Nope. So Xander, I'm sorry, when I click the arrow, it's not changing the slides.
Yeah, I'm sorry about that. Sometimes you have to click in the dual screen. You might have to have the mouse over on the projected screen in order to get it to move. Unless it's frozen completely.
Do you mind if I'm going to stop sharing and restart quickly?
Sure. Yeah.
Okay. So.
Technology has gotten better, but it's certainly not infallible. So sometimes it just takes a little bit.
Okay. But now how do I share? That's the problem.
It looks like it's coming back here. So, okay, we can see the first slide.
Okay, is it working now?
Yes, we're on to the overview.
Okay, thank you. I'm sorry, everybody, for that. So, as I was saying, the wildland urban interface is expanding, and the number and frequency of fires is also expected to increase. So, this two combine, so we have more fires, but we also have more people living in wildland urban areas. It sounds like an explosive combination. A lot of people want to live closer to nature because nowadays we have increased broad access to better communication, better roads and transportation technology. So what was once wild and isolated, it's now easily accessible. And forest lands in particular are very attractive as residential building sites because they provide a lot of positive externalities. Scenic views, wildlife and bird watching opportunities, shade screening from neighbors, and also easy access to forest-based recreation opportunities. So there's a lot of pressure, consequently, in many parts of the US from residential housing development on both public and private forest lands. So the WUI, or the Wildland Urban Interface, is a very important area where human and environment conflicts can occur. We have habitat fragmentation, we have introduction of exotic species, we have biodiversity decline and loss, but we also have the destruction of homes by wildfires, which is the focus of my study. This is a paper that came out last year, where we were able to prove that the wildland urban interface is the fastest growing land cover class, and it's mainly due to housing growth, not so much wildland increase. I'm going to be showing several papers today, and if anyone is interested, I'm more than happy to share all of them. So, given that there's a lot of money involved and a lot of money allocated to field management and fire suppression, I thought at the time when I came to the US that it would be interesting to try to obtain a better picture of what's going on in the wildland interface with losses, but also with recovery. And so I divided my dissertation in 4 chapters. The first one, I was trying to understand, okay, what are the key variables in building lots? And I divided them in 3 big topics: vegetation, terrain, and the spatial arrangement. And I'll explain a little bit better what the spatial arrangement is, because this was kind of, at the time, novel, and it turned out to be pretty interesting. If I may say so. So I started by obviously let me tell you about the variables first. So the vegetation variables, we looked at vegetation type. We used a lot of land fire variables, land cover, of course. But also I used a lot of landscape variables. So around each building, how connected the vegetation was, what was the percentage of within a certain distance from the building that was vegetation. And so we use FragStats to quantify all these landscape metrics. So this is an example, an image of that yellow dot is the building. There was a radius. In this case, I picked 2.5 kilometers because there's studies that that's how far an ember can fly in a fire, cause a new fire. So this is what I call the landscape context. And I divided the vegetation in highly flammable, flammable, and not flammable. So the spatial arrangement variables, just to give you an idea, for example, there was a study out of Australia that showed that we needed at least to be within 40 meters for the convective heat to be able to start a fire. And buildings that were less than that distance, if one building was on fire, most likely the other one would start on fire too, because they were so close together. So we have that as a variable, so buildings that are within that distance, and then a bunch of others: building density, how clustered they are, how dispersed they are. So we didn't know, of course, a lot of these variables are related to each other, but at the time, let's just put them in a model and see what happens. This was our starting point. And then finally, topography, the usual suspects, elevation, slope, also southwest, which is, it's related to the aspect, but because the aspect can have negative numbers, we created the sen, cosine, sine, is that how you say it? I'm sorry. I'm glad to have my coworkers here to help me. But the most interesting one was the topographic position index, which gives you an indication if the building is at a valley or at the top of a ridge or mid-valley. And I'm mentioning this because this turned out to be more important than all the other topographic variables. So how do I collect my data? So as I mentioned before, I had that army of students, and we used Google Earth. Google Earth has this amazing feature that has images that can go back as far as the 90s. And the US happens to be very well covered with those images. So I started with a small case studies, one in Boulder, Colorado, and another in San Diego, California. This is an example what a Google Earth image looks like. So we have a house before the fire happens, and that's the post-fire image. As you know, it's visually, you can see the house is gone. So this is one of the fires, the one in Boulder, just for you to have an idea. That's the fire perimeter. And so the students digitized every single building that was inside of the fire and either survived or not, or didn't survive. So the results, the criteria to select these two fires in particular were that they needed to contain more than 1,000 structures within the fire perimeter and had burned at least 100 structures. Those were our two criteria. So the main results were that, I don't know why. Oh, I'm sorry. Okay. So of course, there were slightly different between the two fires, but overall topography and the spatial arrangement of the buildings explain most of the variability in the models. And this is an important aspect because of urban planning. Of course, we cannot do anything for the buildings that are already in place, but for future planning, but also for prevention when we have programs like the Firewise or have communities be ready for fires, having this awareness that where the buildings are in relation to other buildings is an important factor. I thought it was a pretty neat outcome. And also the landscape context is interesting. The most interesting thing for me was that it didn't matter what kind of vegetation was in there. It mattered, yes, how connected it was. If it could carry the fire closer to the houses, that was more important than if it were pines or it was the connectivity. So these were two important aspects because they can help communities adapt to fire. And so from this particular chapter, there's also a paper that came out of it, and I mention it again. If you're interested, I'm happy to share. So now the next question was, okay, this was interesting. It was a case study, those two fires. What about the rest of the US? So are these factors the same everywhere? Do they vary? So I divided the US into ecoregions, and the goal was to try to see if these trends would still hold for the whole country. So I looked at fires that occurred between 2000 and 2010. And again, thank God for those students because they digitized a lot of buildings, again, on Google Earth. And so here we had a slightly different approach in terms of methods. On the previous chapter, we used the building as our unit of analysis. There were a lot of spatial autocorrelation issues. So me and my statisticians, we decided, okay, let's have a different unit of analysis. Let's have the cluster of buildings instead of the building itself. And what defines a cluster was all the buildings that were within each other by 100 meters that were all inside of that let's say, buffer, they were considered a cluster. And then what we looked at is percentage of burned buildings inside of the cluster. So then we had a continuous variable, and it was easier to do a linear regression analysis. And so the results for this one, I don't want to go too much in details. I mean, you have the papers if you're interested, or you can ask me later. The results for this one were also, as expected. Of course, there's differences among ecoregions. But again, topography and the spatial arrangement were selected more frequently than vegetation. So that was consistent. So in other words, specific locations in the landscape have inherently a higher fire risk, and certain development patterns can exacerbate that risk. And I think this is the big take-home message. And then again, whenever there was an ecoregion where vegetation would come up as important, again, it was the connectivity that was most important. And this is important because fire policies and prevention efforts are heavily focused on vegetation management, which is important, but is clearly insufficient to solve the current problem. So just to sum it up again, topography and spatial arrangement are struggling, affecting which buildings are lost. Of course, the relative importance of each one of these variables changes depending on where you are. So one-size-fits-all policy, it's not a good idea. These things need to be regionally tailored. That's the main take-home of this paper. And again, this turned out to be a paper in ecological applications. And if someone else is interested, I can obviously share. Okay, so we started with the case study, then we looked at the whole country. And so my next question is, okay, now we have a better idea of what's causing, what's behind it. Can I predict? Can I use the data that I have, the locations of all the burned buildings, and can I extrapolate? And this brings me to my other chapter, which is, okay, where are buildings more vulnerable to wildfires? And the idea, this is a conditional probability. If a fire occurs, where are we more likely to have building losses? And so the idea is to build a vulnerability map. And I used the same ecoregions just because it's to compute models for the whole US can be quite heavy on the processing side for computers. So we also thought it made sense ecologically. So again, we used the real observations from the lost buildings from 2000 to 2010, and we used a Maxent model. Maxent is a model, stands for maximum entropy. So it's normally used in biology and ecology to predict species distribution. So we kind of used our buildings as our species of interest. And we were saying, okay, if you're seeing a building here that in this case was destroyed, what are the characteristics of that site that are similar in other places? So that means that's at risk. So we decrease the number of variables here. We're not just throwing everything at the model. So now we had a better idea. So again, we use land cover. MSPA is a measurement of fragmentation, how fragmented the landscape is. In this case, we just used a simple classification of forest, non-forest. And then the elevation, slope, and southwestness, and some variables that would mimic the spatial arrangement of the places. And we did this, each variable was a raster with a 30-meter resolution pixel, so for the whole country, but we kind of clipped them per ecoregion. And so the results were, the Maxent models were actually surprisingly good. So for you to have an idea what AUC means area under the curve, and what it means is if you have a 0.5, it means it's no different than flipping a coin, having a 50% chance. So anything above 0.8, which was our case, means that the models can at least be considered useful, and in some cases they are highly accurate in their predictive performance. So as you can see here in this map, there's a clear difference between the west and the east, which is expected. The western part of the US presents higher vulnerability in clustered patterns that are closely related to either topography or land cover, while the eastern presents a reticulate pattern that it's more closely related to populated areas. And we think the maps are of major importance for local government agencies that want to plan ahead, because if you zoom in, they're highly detailed. So at a 30-meter resolution, it's a pretty good resolution. So at this point, we had a case study, try to understand and explain. We tried to predict, and now it became the part where I was curious, okay, what about recovery? What happens after someone has their home destroyed? So the idea was to look at what happens. In this case, as an example, there was the same example we saw before. There was a house there, then it was destroyed. Is it going to be rebuilt? So we had a smaller window this time around. We looked at fires between 2000 and 2005 because we needed to give enough time after the fire, and in this case, we limited to 5 years post-fire to see what was happening. We thought more than that, we couldn't really tell if it was related to the fire anymore. And so the interesting part about this chapter was that when I was training my students and collecting data, I realized that, not only there were buildings being rebuilt, but there were new buildings inside that weren't there before. So I told them, just in case, I don't know what I'm going to do with that yet, but just collect that data. And it turned out to be interesting because the results show that there's more new buildings than rebuilt buildings inside a fire perimeter. And so when you look at an overall fire perimeter, the percentage of buildings that is actually destroyed when you compare to the whole picture is low. The idea was to have a snapshot of those 6 years. So we summarized the data per different ways. We did it per fire, we did it per state and regions. But the overall trend was that rebuilding is low and there is new developing occurring after wildfires. So the take-home message for this chapter was that, okay, when people are not rebuilding, this may or may not indicate that they are adapting to fire because it's a choice not to rebuild and they decide, okay, I don't want to live in this risky area anymore. However, the occurrence of new development shows the opposite, that either people are not aware of the risk or that the amenities of those areas outweigh the risk. They are aware, but they still want to build it. And so again, I also have a paper with the results if you're interested in knowing more details. So just to summarize the overall take-home message of my dissertation is that we should focus on prevention and planning and community preparedness and adaptations. So the housing growth is going to continue to happen. We know climate changing is happening. This is a problem. So I think we should focus, again, prevention, planning, and having the communities ready. We also, interesting thing about the results of my dissertation is that they were aligned with other researchers and other studies from other parts of the US that we all agree there's no single solution and there's not a single factor that it's most important when we're managing wildfire. And that's why it's so important to have, more regionally tailored approaches and, see with each community what can we do. This was something my advisor asked me to do at the time when I presented this. And he said, okay, so can you provide people with what are possible approaches? I come from Europe where there's a strong government intervention, there's regulations and laws in place. And the US tends more to be let the homeowners bear the risks. Although in truth, there's a lot of resources allocated to protect houses, so it's a mix. There are precedents for all of these options. Like I said, Europe is heavy on regulations. In the US, the approach is to fight and the priority is given to protect property and lives. Although there's more and more communities that have adopted the Firewise program, which is great to see. Argentina, for example, has neither regulations nor mandate to protect property. So either we're going to adopt one or a combination of these alternatives. It's something that we as a society need to decide, or communities locally will have to decide which approach works best for them. My hope is that my research and my results may help us move towards more situations like this one, where fire comes and the house survives, because there were good practices, there was good prevention, there's awareness of, what can cause the house to burn. That's it. Thank you.
Excellent. Thank you. That's I'm amazed that you were able to, in a clear way, present all those different chapters, all the different papers. We did have a couple of good questions come in. First off, there was some discussion earlier on about the number of homes burned or destroyed in 2018. I guess there was some question about where you pulled that number from.
The fire agency website, the report.
Okay. So yeah, some people made a comment that maybe just data from California suggested there were more homes, and I would suggest that perhaps that's due to how often NIFC updates that number.
Yeah. So that was an important distinction I didn't mention. We use the word buildings because when you're digitizing, you can't tell if it's a house, if it's a shed, if it's residential or commercial. So we decided they're buildings. The report divides. So it says, if I can go back to my notes, because I had that on my notes. Okay. So they said there was a total of 25,790 structures, including 18,137 residences, almost 7,000 minor structures, and almost 300 commercial mixed residential. So this number breaks down into other categories.
Yeah, and those are all from NIFC, and I maybe can provide the web address here in the comments.
Mm-hmm.
Another comment came up about the WUI, the idea of the wildland urban interface, and also this idea of an agency interface area. And at least on the sort of operational side during a fire, that one of the questions is this jurisdictional and making the confusion potentially of who is in charge before, during, and after, whether it's an urban firefighting agency or a wildland division or the U.S. Forest Service or something. And so I think that's a worthwhile point, but a little bit to the side of our current conversation.
Yeah, I'm not familiar with I think it really depends who gets there first, gets the command. I think that's a tradition here in the U.S. It might be changing, and maybe other people in the room know.
Yeah,
it is outside of the scope of my research.
Yeah, it's a really important question, and I think that know we certainly see it in communities across the West, but I think it's an operational issue at some level.
Mm-hmm.
I thought maybe we'd turn our attention to Molly Mowry brought up the building construction materials and construction approaches. Did you factor that in at all?
No, at the national level would be pretty impossible to do so, but it always, every time, every reviewer, every conference I go to, everybody raises that question, which I agree, it's super important. But again, we wanted to have a national idea of the, just how do I put this in words? We know materials are important, but in this case, it was just impossible to collect that kind of data. And but it's converging. I mean, these results converge to the home ignition zone studies and research that has been done. They don't go against those results at all. On the contrary, they just strengthen them.
Yeah. Okay, that makes sense. So they line up.
Yes.
Let's see. looking down through the questions, I did paste in a number of the publications into the chat window, so folks can grab those from there. A few people asked about continuing education credits, and again, this is a side note, but we didn't set that up in advance. But folks are welcome to email me if they need verification that they attended, and then often you can submit that on your own. I should note that one of your co-authors, Miranda Mochran, presented on a webinar for the consortium a little while ago. So that video is online. And so if this is, maybe I'll paste that into the chat window. If this is a topic of interest, folks can go back to that presentation as well and watch. That's the latest link I put in there.
Alexandre, if I may,
Sure.
So for my PhD, the time frame with fires between 2000 and 2010, but I helped, so before I left, I helped collect more data. So now the data set goes up to 2013, and there was more research done with a new postdoc that came after me with that data that is quite interesting. And I have, I'm sorry, this is a little fast. I lost it. Oh. Interesting. I was just going to share those new. I don't know why I lost.
Okay, you can also paste those into the chat window.
Yes, there's new research that came out of. I can't do it. It's okay.
Okay.
And also, I'm sorry, that data set is available. If anyone is interested in looking at the data set, we have digitized buildings from 2000 to 2013 at this point.
And that would be available via the Silvis website?
Or, I don't know, I'm not sure if it's on the website, but if you contact the Silvis lab, they will provide the data for sure.
Yeah, and I that's a good point, because I know personally I've used data from the Silvis lab in fire protection plans and on the ground work here in New Mexico. So that's a great resource to mention.
Yep.
So let's see, going back to some of the other questions in here. Stephanie was asking about gray areas on the map of the US, and I'm not sure.
That's probably the vulnerability map.
Yeah, yes, that's right. Were those areas not studied or too low population to be at risk for building loss, or there was some other reason?
Yes, the ecoregion didn't have enough observations for me to consider it for the models. So
Okay.
we set up a minimum of 40 burned buildings within each ecoregion in order to run the models. We thought under that the results wouldn't be very significant.
Yeah, no, that makes sense. And I think that probably gets back to one of these issues about the particularities of an individual structure, what it's made of, et cetera, and why it burns that you can capture. Let's see. So I think Stacy had a question that we may have touched on already, but it's worth sort of reiterating or asking in a different way, perhaps. So Stacy asks whether you looked into seeing if buildings lost were more or less likely to be fire-wise, fire-safe, or if home hardening was a factor, new homes versus old homes, that another potential factor.
Well, that was one of the papers I was going to show you that came out after I left with the new postdoc. She looked at where the Firewise programs are located in the country in relationship to the number of burned buildings, and it's a very interesting paper. I think that one is out because we have two in review right now. And so, yes, we were very curious. And an interesting result that I can share with you right now is that when we first looked at the results, she was saying, oh, it's interesting, the places where more buildings are burned have the Firewise program. That seems counterintuitive. And I said, well, did you look at the timing? Because it sounds like there was a fire, there were building destroyed, and then they adopted the Firewise program. And when she put the time factor into consideration, she's like, you were right, it happened post. I was like, yeah, it would make sense to be the other way around. So that is an interesting result. The Firewise program seems to be having an effect, and that was a pretty cool outcome of that research.
Yeah, no, that's very interesting and makes a lot of sense as you start to think about it.
Yeah.
Let's see. Crystal asked about the study identified 40-meter separation of buildings that posed a threat of fire by spreading radiant heat. Was there a size of building that was identified? For example, if the building was accessory in use, there was a threshold of building size. If it was smaller than 120 square foot building, can the 40 meters be reduced to some number where it would not pose a threat to the adjacent building?
No, we did not look at the size of the building, no.
Okay. But I see that's an interesting question, because identify proximity of other buildings as a threat, just the way we've identified sort of that defensible space zone. We as a community may need to do more research to figure out that issue. Like, as building size change, essentially the fuel that might burn in an adjacent building, that may change our view a little bit.
Yeah.
Let's see, other questions. Monte asked a question about the insurance industry, and I think it's maybe a little bit outside of today's presentation, but I know there's some folks from the insurance industry on the call. So I can answer the basic question: has the insurance industry been consulted or involved with helping with fire prevention and resilience? And the answer is yes. There's certainly a lot more to that conversation. I don't know, Patricia, if you had any interaction with folks from the insurance industry in your research, or if you've had people follow up with questions.
There's always that question from the audience. And we had anecdotal, interactions with agencies that want to go that route. But back then, the money the insurance were losing to fires wasn't significant enough in comparison, for example, with flooding. So it was a slow process, but it was something I was very interested in, because the US is so averse to regulations that maybe the route would be the insurance companies. Okay, if you want to have your house insurance and you live in a forest, you need to do these and these actions to mitigate, fire risk. So it was something I was very interested in. It is a very good question, but I didn't look at it.
And I think that would be a good topic for a future webinar. So if there's somebody on this webinar who would be interested in either connecting me with somebody who can talk intelligently on the topic or could do so themselves, please do get in touch, because I think it is an ever-changing element of why homes burn in the wildland urban interface. And I think this past year will continue to change things. So thanks for bringing that up. Let's see. Marie Claire made a comment about defensible space and the importance of defensible space grant programs. That's obviously a pretty, there's a lot of conversation there, and I would say that there are some experts on the call today who spend a lot of time on implementing defensible space grants, although there never seem to be quite enough to go around. And so we actually have some insider information. Rose makes a comment that the last home in the presentation actually had a lot of air support to save it during the Taylor Bridge wildfire. And so it was defensible. It was not only defensible space, but also the air support. And I think that gets back to the individuality of every home and every situation. And certainly of the things that we've seen is the importance of giving firefighters the opportunity to protect homes. Just trying to go through these comments here. Let's see. There are a lot of great contributions, and if you're not able to scroll through the chat window, I encourage you to try to open that up. And thank you, Stacy, for sharing the building data set. That's great. It's a great addition. So Bob asked about whether you looked at the northeastern aspect in Southern California. And then also this issue of whether anybody was present defending the structure, time since last fuel treatment. Were any of those other factors things? I know you looked at aspect, but did you look at the presence of firefighters in the possibility of burning?
No, again, we thought about it, but again, at a national level would be really, it's information that is highly inconsistent. It's pretty good in California, but not in the rest of the country. But we know it is important, of course. These are all things that went into the caveats of the papers. These are all aspects that we know that should also be considered, but at some point in research, you need to move forward and work with what you have. Yep.
And it certainly sets the stage for these next set of questions. Let's see. Good. Well, I think I covered most of the questions in here.
I have at least one or two people in the room that have questions too. Is that okay?
Oh, great. Yeah, please.
My question is, I was curious, what about the topography and spatial?
That's a good question. So in case of the topography, for example, if a house is in the top of a ridge, the fire behavior is an aspect because it gets faster to the house. So the conditions are more extreme. In case of the spatial arrangement, it is once a fire hits a community and hits buildings, the fuel is no longer vegetation, but the buildings themselves. And so it's the progression from building to building that becomes important. And this is a very important aspect because a lot of firefighters that are trained in forest fires don't have the training for urban fires. It's a different beast. So that is a very good question. And that's why this is so important. Megan, do you have? No, I think that's it from the room.
Okay, and it looks like someone got in touch with me about some potential insurance industry contacts for future webinars, so I appreciate that. So I know that you've taken a new job, Patricia, and probably has a different focus. Are you personally going to continue on any of this research, or have you kind of taken a new tact?
Well, I did go back to Lisbon for a postdoc where I looked at the wildland interface in Portugal. So there's some loose ends there. There's some papers that I would like to publish still. But within the DNR, no, the focus is not fire, unfortunately, but it might be one day. I keep my eyes and ears open. I'm interested, and we'll see.
Yeah, sounds good. Well, I think let's see. Okay. Yeah, another comment about insurance. So I appreciate that. But I think we're probably able to wrap up here. I think there's a lot of good conversation, but no additional particular comments. So I want to thank you again, Patricia. I think it's really good to get this research out, and I know for myself it sort of motivated me to look back at the papers and really pull out those examples, because I think it's certainly relevant right around here to where I live in Santa Fe, New Mexico. And I think policy level, there's some really good implications across the country.
Well, thank you, Xander, for the invitation. It's really nice.
Good, and thanks everybody for participating. It's great to see so many people on the line, and I hope to see you on future webinars. And with that, I'll close off the event. Thank you.